Assalamualaikum warahmatullahi wabarakatuh and good day to all the panel, Dr. Adnan bin Rosli and IRTS Dr. Lailatul Harina binti Paijan. This video will be the presentation for my bachelor degree project 1 that titled Development of 3D Model of and Bathymetry Contour Map for Sungai Melaka using AutoCAD. My name is Ahmad Zairy bin Jamaludin. Matrix number B091910062. Course Bmma Bachelor of Mechanical and Manufacturing Technology, Automotive Technology, and from Faculty FTKMP. My supervisor is TS Sheikh Ismail Fairuz bin Sheikh Zakaria. There will be 6 items contained in this presentation, namely introduction, problem statement, research objective, literature review, methodology, and preliminary result. Introduction. Contour map or topographic map is a kind of map that shows the elevation of Earth's surface structure using contour line. The contour line helps visualize the elevation above sea level or depth below sea level. The contour line will connect to the location with the same level of elevation or depth, creating a long curve and certain spaces that indicate the relative slope between other contour lines. The contour map usually comes in color with color scale to help the reader to determine and distinguish the level of elevation. As we can see here, on the left is 2D version of contour map. We have it in different color in the different contour region and color scale on the side. And here we have the 3D version of the contour map, and the bottom one show where the contour line is in the real Earth surface structure, as we can see here. Problem statement. Number 1. The Melaka River have almost no record of data on bathymetry or hydrographic study, and there is no representation of the underwater landscape in any shape or form. So for this particular problem, the data that I get for hydrographic studies is just about the research about pollution, so it's not very relevant to my project. Number 2, the problem statement is the constant shift in the underwater topography of the Malacca River is causing concern that it may pose a serious threat to the local industry that rely on the river in daily basis. So it was concerned that the underwater topography is not safe enough to be used for to the local and other industry like the Malacca River Cruise or local for fishmongers. Number 3, project objective. So projective number 1 is to get and process the high volume of data obtained from departure plus and convert it into usable data for the AutoCAD program. Number 2 is to develop a 3D contour map of the Malacca River using AutoCAD based on the obtained data. Number 4, literature review. So, literature review number 1, titled Identifying the Source of Pollution in the Malacca River using the GIS by Dr. Ang Kian Hua from Quest International University in 2017. So, the strength of this paper is introductory on Malacca River Basin and Sub-Basin location, which is maybe helpful to me in my project. The weakness is not so much on bathymetry study related information presented. So, as the title suggested, this paper focus more on the pollution study on the pollution in Malacca River. So they do not really focus on the structure of the river itself. So the notable feature is using usage of GPS to locate the position of basin and sub-basin. So this project, my project, this bachelor degree project is I will also be using the GPS to locate the location for my study area, study region. Number 2 is mapping bathymetry by Dr. Alasdair James Edward and from Newcastle University and Dr. Peter Mumby from University of Queensland in 2000. In year 2000. So the strength for this particular research paper is it gives a lot of information about bathymetry maps. The weakness is more to technical aspect of bathymetry mapping and its intricate. So this research paper use the use I name one method that they're using to uh, in their mapping bathymetry like Juke methods. Sadly, I'm not going to uh, go to research on that kind of bathymetry. Instead, I'm just going to get the data for the bathymetry, not on the really the technical aspect of the how bathymetry mapping is going to be done, because I'm not really going to be using that kind of information. So the notable feature is have an interesting element like remote sensing that might or might not be useful for this project. So since this project is not very finalized on what I'm going to use, uh, remote sensing feature might be used, or maybe I'm going to use it. Literature number 3 is 3D modeling and visualization for landscape. So this is from Dr. Davis Dinkov from Bulgarian Academy of Science and Professor Romina Batseva from National Institute of Geophysics, Geodesy and Geography in year 2016. So the strength for this research is the abundant information regarding the 3D modeling process, and the weakness is not using the same software as the project. So they using a completely different software, and like me, I'm just going to use the AutoCAD software, which is because the is research on 3D modeling is very detailed. Even the house will be visualized in uh, this paper. So I'm not going to be doing that. So it's a bit shame. So because I can't really use, but it is very like the notable feature, a very structured procedure. This this paper is give a very structured procedure and general step-by-step process with an illustration. So for someone that are going to use the same software is going to be very useful, because it is very informative, very detailed on what they are doing in this 3D modeling. So literature number 4 is single beam bathymetric data modeling technique for accurate maintenance from Professor Ahmed Al-Hattab from Port Said University in year 2014. So the strength of this apa what research paper is a relatable take on data acquisition process and may proven to be useful. The weakness is bathymetry study presented are giving too much focus on the technique that this project will not be using. So this paper is focused on how to take the bathymetry data. It's so focused that I'm not going to be using it. So it's a bit shame. So the notable feature is the data recording part of the echo sounder in this literature is neat. Number 5 is methodology. There are 3 methodology that I'm going to use is number 1, data acquisition, Number 2, data processing, and number 3, 3D model development. So number 1, data acquisition. So I'm going to collect the data for this project from a section of Malacca River, 100 meter of it to be exact, and nearest to Taman Rempah Fasa 1. The equipment that will be used is RC board, departure plus, and smartphone. The departure plus will be mounted on the RC board, so it can be controlled remotely, and the smartphone will be used to monitor the underwater structure during the scanning process. So if the underwater structure is not very not very deep, we going to be a little bit more to the mid of the river. So the plan for obtaining the data is by having the departure mount on the RC board, like I said before, to move perpendicularly to the river repeatedly until we cover about 100 meter of the river as shown in the diagram. As you can see here on the bottom left side, the repeated perpendicular movement of the departure and spanning on the river spanning about 100 meter of it. I am going to be collecting the data this way. So methodology number 2 is data processing. So after the data obtained, I need to do conversion of the data because in raw format, the data which is latitude and longitude data format value come in decimal degree, where the form that I'm going to use is UTM, Universal Transverse Mercator, because AutoCAD program only accept the value in UTM format. So the 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 tool that I'm going to use for this conversion is ArcGIS conversion template, which is an Excel file. So this template is all I need to do, is all I need to convert, because all I need to do is to put the value of the data in the decimal degree, and it will automatically convert into the UTM. Methodology number 3, which is 3D model development. As the title project suggested, I am going to use the AutoCAD software to develop the 3D contour map. But what version that I will be using is still need to be considered, because at one point in my research there are content that show that it we can just use the normal version of AutoCAD, which I already have, or I can also use the AutoCAD Civil 3D, because in what I have seen, the using AutoCAD Civil 3D give a little bit more clarity to the model itself, and also more precise. So that's that. So number 6 is preliminary results. So due to the lack of my own skill and knowledge on what is the precise way to develop a model of 3D bathymetric contour map, added by its extreme complexity and time constraint, it was decided that the preliminary result that will be shown is an sample of figure that were taken from the internet. The figure that was shown is not the representation of the actual final model, but rather as a way to give the viewer an idea of what the model might look like when the process of development. So as you can see here, the figure number 1 is fetched from the Golden Support website. It is actually imported model from another software into the AutoCAD, the basic AutoCAD program. As you can see here, detailed but not very informative. And the right side is 3D model using the AutoCAD Civil 3D. As you can see here, there are we can put a color, and the white dot here is actually the elevation of the structure. Very detailed. I might be using the AutoCAD Civil 3D. Who knows, right? And this is fetched from the YouTube. This is the way on how to import points, the data into the AutoCAD program. So there is not much to be said about the anything else. So I'm going to finish my presentation here. Thank you very much, and wassalamualaikum warahmatullahi wabarakatuh.